So for number 5, our first step is to factor the denominator. So this is something that was done previously for us. So let's factor the denominator. So factor out an x first as a GCF, and then we can factor that trinomial. So that'll be x minus 1 times x minus 1, which I do want to write that as x minus 1 squared. So this is going to be x plus 2 over x times x minus 1 squared. Now this one's going to be a little bit different, so we have a couple things going on here. The x, that's just a normal linear term, so that's a. But the x minus 1 squared, this is what's called a repeated linear term. So let me write that here. This is what's going to be called a repeated linear term or linear factor. So how we deal with that is I need to build up to the power. So I can't just put x minus 1 squared as my denominator here. I need to start out with an x minus 1 and then go up to an x minus 1 squared. So I want to just take a quick second to kind of explain that again. So I'm going to pretend that, let's say this was something over x times x minus 1 cubed instead of x minus 1 squared. Then you would have to have a over x plus, and then you need to build up to that x minus 1 cubed. So it would be b over x minus 1 plus c over x minus 1 squared plus d over x minus 1 cubed. So you need one of each of the previous powers. The reason why you need this is because, let's say you had something over x plus something over x minus 1 squared. So I'm going back to the squared one. I don't care anymore about the hypothetical cubed one. And also, let's pretend you could also have something over x plus something over x minus 1 plus something over x minus 1 squared. So we're trying to figure out like the LCD. The LCD of this first one between x and x minus 1 squared is x and x minus 1 squared. But the LCD for the second one is also x and x minus 1 squared, because it's the greatest number of times it appears in any one denominator. So you have an x minus 1 here, you have an x minus 1 twice here, so you want it twice in your LCD. So because these two expressions have the same LCD, then when we break it up, we need to use this one, because it's possible that you'll have that x minus 1 term that you're not accounting for here. So we need to account for that possibility that you might have an x minus 1 term. If it doesn't have an x minus 1 term, if it really is like this, then all that will happen is that this will be a 0, and then it will effectively cancel out. So that's really the rationale why we have to use, or why we have to build up to the factor, because they both have the same LCD. It's kind of ambiguous. So let's get back to our actual problem. This is going to be our partial fraction decomposition. So I do want to multiply by my LCD. So it's going to be the x times x minus 1 squared over 1. Again, I'm multiplying both sides of the equation by it. And let's go to another slide. So it's going to be the x plus 2 that's left over on the left. We have an a times x minus 1 squared plus b times x minus 1, and then plus c times x. So I want to FOIL out that x minus 1. So x squared minus 2x plus 1, and then plus bx squared minus bx, and then plus cx. And then finally I want to multiply the a. So x plus 2 is equal to ax squared minus 2ax plus, not 2, plus a. And I'm still copying the other ones. Okay, so I want to now group the x squared terms and the x terms, and then the terms that don't have an x or an x squared, I want to put those at the end. So I have x plus 2 is equal to ax squared plus bx squared minus 2ax minus bx plus cx plus a. And then I want to factor the x squared and factor the x. So I'm going to go to another slide. So you should have x plus 2 is equal to x squared times a plus b plus x times negative 2a minus b plus c, and then plus a. So now I want to equate my coefficients. So I have an a plus b on the right-hand side being multiplied by an x squared. I don't have any x squared on the left, so it's like it's a 0. So my x squared equation is going to be a plus b is equal to 0. I have a negative 2a minus b plus c multiplied by an x on the right, and I have an implied 1 being multiplied by an x on the left. So for my x equation, it's going to be negative 2a minus b plus c is equal to 1. And then I have an a on the right, and I have a 2 on the left. So my constant is going to be a is equal to 2. So if you do the matrix and you do RREF, you should get 2, -2, and 3, which means our final answer is going to be 2 over x plus -2 over x minus 1 plus 3 over x minus 1 squared.